Hello guys, welcome once again to the Senior High School Mathematics Forum, and we are going to deal with differentiation without first principles, meaning we are going to treat that topic, how to differentiate functions without first principles. So when we are to differentiate functions without first principle, we use we use this differential notation. That is f of if a function is given as f of x is equal to a multiplying by x power n, then its differential will be f prime of x is equal to a multiplying by n multiplying by x power n minus 1. Have you seen that? So now someone may ask, so this one is the differential notation. Someone may ask that how did that one come about? So we are just going to use, for that sake, we are just going to use first principle to drive this one so that the rest of the things we will be doing will not require first principle again. So in using the first principle, we put the first principle equation down. So we say that f prime of x, that one is equal to limit as h approaches 0. That's we are proving this one to be this. So limit as h approaches 0 of the expression, the whole expression f of x plus h, that is f of that expression, minus f of x all over h. Have you seen that, guys? So as we are proving this to be this, we quickly find f of x. So and f of x is the same as the original function, because I always encourage you to solve each part separately before you bring them together into the first principle equation, in order not to make a mistake which will lead you into a wrong answer. So getting the f of x will be equal, getting f of x will be equal to ax power n. Have you seen that? So meaning a multiplying by x separately, that x alone is power n. So we will now have f of x plus h, that is f of that expression, to be equal to a multiplying by, wherever you see x in the original function, you put x plus h there. Hope you've done functions. So this shouldn't be a problem to you. So a multiplying by x plus h. Have you seen that, guys? Power n, that expression power n. Now, someone will say that how are we going to subtract these two um um functions, these two different let's say expressions, without knowing n? And we can't even do so. We can do so because you are a mathematician and you need to think widely. So in thinking widely, we realize that we can apply the knowledge of binomial expansion here to the second expression. Have you seen that? So using binomial expansion to expand the second expression, we will have that as, the second expression is a multiplying by, that is x plus h power n. So using binomial expansion for that, we will have it as a multiplying by, and you know how we use binomial expansion. If you don't know, quickly check on my videos. I'll drop that one too soon so that you will check. So we have a multiplying by the whole of, then you expand this expression. In expanding that, note that the powers of x and h, when you sum them, you should get n. That is one thing about expansion. And then two, you know that as the powers of x is decreasing, the powers of h will be increasing. Have you realized that? So now let's move on. And there are some specific coefficients allocated to them, attached to them. So if you want to know, I'll just put those coefficients straight there and move on. If If you want to know then why they are so, and then you join me on the binomial expansion topic that I will be dropping. So now, guys, it will be x, the expansion will be x power n multiplying by h power 0. Though it is not sensible to do so because h power 0 is 1, and then 1 multiplying by this is still x power n in mathematics. But when you are explaining to someone, it is advisable to do so. So we now have plus, this was what I was talking about, n, that's the coefficient. You don't know how it came about, so don't worry, just use it. Or if you also learned binomial expansion, then you are lucky. So plus n multiplying by x power n minus 1. I told you that powers of n will be decreasing, and then multiplying by h. Have you seen that? I told you that also the powers of h will be increasing, so that will be power 1, and it is not sensible to write power 1 in mathematics because h power 1 is still h. So because I'm explaining to you, it is advisable to do so. So now we will have plus, have you seen how it goes? So these coefficients will be the one you will not understand. So plus n multiplying by n, if I'm to explain, they really came from combination and those things. But if I'm to explain, it will take much time of my video, and I won't really tell you what I was about to. So plus n multiplying by n minus 1 all over 2 factorial, multiplying by x. That one, the powers decrease, n minus 2, then multiplying by h power 2. Have you seen that? I told you earlier on that when you add the powers, you should get n. So try that and see. I hope you are done. So let's move on. So plus dot dot dot, then plus. The dot 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 means an infinite expansion. Plus, we know the last term, but we don't know the middle terms. So plus x power 0 multiplying by h power n. So if you don't know the middle terms, it doesn't mean, if you know the last term, it doesn't mean that it is a finite expansion. No. If you know the last term and you don't know the middle term, rather, it doesn't mean it's an this thing. It's a finite expansion. So moving on, what will we do? So knowing that this will be our expansion, we now say that let's expand this by multiplying a to all of them. So this will now be equal to a x n, and h power 0 is 1, as I told you earlier on. So we won't bring it here again, plus n multiplying by x power n minus 1, and then h power 1 is h, then plus n multiplying by n minus 1 all over 2 factorial. Have you seen that? Multiplying by x power n minus 2 multiplying by h squared. Have you seen that? So this is how it will be, plus the dot dot dot. Have you seen that, guys? So when you bring plus the dot dot dot, then you bring plus x power 0 is 1, we will not bring that one, h power n. Have you seen that? So this one is too large. So guys, what we will do is that we simply do the subtraction and then now substitute everything there. Do the necessary things and substitute everything there. So guys, realize that this in the function f of x is common to this. Is it not true? It is. So sorry, bring the a's. You have to bring the a's. The a's is multiplying by each of them, and even in the infinite series, the a's are multiplying. The a is multiplying by each of them, rather. So let's move on. So we will now have it to be equal to. So subtracting, let's say, subtracting both expressions, that's f of x from f of x plus h, we will have this going away with that. Have you realized that? So we will now have it as f of x plus h minus f of x to be equal to, this will not be there again. So this was plus, not tan, plus a n x power n minus 1. So we now have it as a n x power n minus 1. Then we'll have h here. Then we'll have plus, that's this subtraction straight. I'm not putting anything like into the function before, into the equation before I do those things to be cumbersome. Then x power n minus 2. Then we'll have h plus dot dot dot. This in that. Then plus a h power n. Then because our aim is always to do away with getting an undefined expression or value, we will have to factor. We know that h is common among these terms. H is common among these terms. Oh, this video. H is common among these terms. Why do this? So we'll notice that H is common among these terms. So what we will do is that we will factor H out. So in factoring that one out, we will have H, and we can factor A2 out. We'll have A, H. Have you realized that? Then we'll have into bracket N, X, N power N minus 1 plus N multiplying by N minus 1 all over 2 factorial, which is still 2. I will just leave it that way. Multiplying by, this is H squared. So multiplying by H, 1H now. So meaning if you factor H out in this, because I told you H will be increasing, if you factor H out in this dot 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 dot, dot, it will now be left with H power 2, H power 3, H power 4 onwards. So we'll have it as plus dot 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 plus plus h n minus 1. If you factor 1h out, meaning you are removing 1h from this, that is, you are dividing by h like that. And if you multiply by h again, that means that you will get this, you will be adding their exponents, which will give you n, and that will be here. So getting this way now, we can substitute this into our gradient, our first principal equation. Then we will have it as f prime of x is equal to limit as h approaches 0 of this, of ah bracket open, n multiplying by x power n minus 1 plus n multiplying by n minus 1 all over 2 factorial multiplying by xh, then plus dot dot dot, that's an infinite expansion, plus h power n minus 1. This in that, guys, then bracket close, and this expression is all over h. So now cancelling the h out, then substituting 0 in, guys, what will we get? Substituting 0 in, we will get it as, see that this will now be n, this will now be a multiplying by n multiplying by x power n minus 1 plus n multiplying by n minus 1 bracket close all over 2 factorial multiplying by x multiplying by 0 and then plus dot 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 dot. Notice that, as I told you earlier on, in this dot 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 dot, h will be there throughout. H will be there if whatever infinity term it is going to, h will still be there. So that all those terms will be zero. So don't be like it is not true or something like that. It is true, because since h is here as 1, h will be there, h square will be there, h cube will be there, and continues till h power n minus 1. So we now have plus 0 power n minus 1 and 0 power any number is 0 except 0 power 0. That one is like a mystery, but it's like a mystery, but some see it as 1, but that comes with a lot of explanations, but I haven't learned deep into that, so I'm yet to do so. So now, getting this, we realize that all this will be 0. This, because of this 0, this will be 0, and this will be 0 as I explained, and this too will be 0. Have you realized that? So now we will get it as a n multiplying by x power n minus 1, and this is our answer using first principles. So this thing is our answer. Have you realized that? So that's differential notation. So that is our answer. So we've used first principle to get this. Now we will use this without using first principle, because that one is a long procedure and this one is a short procedure. You just look at it, differentiate it once without using first principles. So let's quickly solve questions so that you will see how we use the differential notation without using first principles. So good. Let's say our first question is f of x is equals to 5x cubed plus 3x plus 4. Good. And f, that is it. So, and we know that if f of x is equal to ax power n, we will get f prime of x to be equals to n multiplied by a multiplied by x power n minus 1. Have you seen that, guys? So when you come to this particular function, how to differentiate with the differential notation is, looking at this one, we'll see that we multiply the exponent and decrease it by 1. Is that not it? So now we will come here, we'll do it to each term. So we'll have f prime of x is equal to this video there, actually. Okay, we'll have f prime of x to be equal to we'll have f prime of x to be equal to we'll have f prime of x to be equal to we'll multiply this by that, and we'll maintain the coefficient as you can see here. So we'll multiply 5 by that. So we'll multiply 3 rather by the 5, the coefficient, multiplying by x power 3 minus 1, will decrease it by 1, the exponent by 1. Have you seen that? Same here, multiply 1 by 3. It is not sensible to do so, but I'm explaining to you how to use the differential notation. Then multiply it by x power 1 minus 1. Have you seen that? Then this will be plus 4. Then how do we differentiate this 4? This will be plus 0, and then why is it 0? Because we are differential of a constant is 0, 4. So why am I saying so? And you attach x power 0 to the 4. Have you seen that? And x power 0 is 1. 1 multiplying by the 4 is 4. That's why I'm saying attach x power 0 to it, so that you get y is 0. So then now multiply the 0 by the function, the distance, the 4 times x power 0, and then now decrease the exponent by 1. So now we realize that 0 multiplying by the whole of this will be 0. Have you realized that? So that's why the differential of a constant is 0. So we'll get it as 15x power 2 plus 3. So have you seen that? So guys, because 1 minus 1, 0, x power 0, 1. So this is our answer to this without using first principles. If it had been first principle, it would have been long. We wouldn't have gotten the answer by now. So let's solve another one. Let's look at this. If you have a function like this, f of x is equal to um 3 over x cube 3 over x cube plus 5x then plus x cube. How will we do it? How will we differentiate this one? Good. This is how we will differentiate it. Now, using same differential notation, this is how we will differentiate it, guys. You first rewrite this function in order to be differentiable. So in rewriting this, you will have to apply your indices knowledge there. When this is having an exponent of positive and you bring it on top, it will have an exponent of negative. Have you gotten that? And if it is having an exponent of this thing positive, negative rather, and you bring it on top, it will have a positive exponent. So that's how we do it. And then plus 5x. You have to use indices knowledge here as well. Plus x keep. Someone will say we should add this to this. Notice that they are not the same, guys. We can't add them. They are not the same. Now moving on to differentiate, as I told you earlier on, the first differential, that's f prime of x, will be equals to minus 3 multiplying by 3, then multiplying by x power 3 minus 1, you decrease it by 1, then plus 5 plus 5 x power 1, then you multiply 1 by that. Have you seen that? Decrease it by 1, then plus multiply 3 by x power 3, decrease it by 1. So now you get minus 9 x power minus 4 plus 5 plus 5 plus 3x squared. So rearranging, we'll have the answer now to be 3x squared 3x squared minus 9. Rewriting this will be all over x power 4. Have you realized that? Then plus 5. So this is our differential. This is our final answer to this question. Differentiate this rather. Yeah. So now moving on, we'll solve our last question on this section of the differentiation, so that I will lead you into another section. So now we have a question. We will have a question to solve. So, and what does that question say? It says that f of x. It says that f of x is equal to um x squared plus 1 all squared. Have you seen that, guys? So this one we could have this one needed this one we can apply rules of differentiation to it and then solve it easily. We can also use the differential notation to solve this. But note, you don't know the rules of differentiation. That is the product rule and quotient rule. Even if you know, we should assume that we don't know. So in the next video, I'll be dropping that one. So now, how do we solve it? If it had been that one, you would have solved it without doing anything. But this one, you have to expand first. So we'll have x power 4 plus 2x squared, then plus 1. Have you seen that? This is the expansion. Then if you are now differentiating, have f factorial of x to be equal to, same as I told you earlier, on multiplying 4 by x, then power 4 minus 1 plus 2 by 2 multiplying by x power 2 minus 1 plus 0. That is differential of constant is 0. Then you have 4x cube plus 4x plus 4x. If you want, you can factorize 4x out. If you want, you can leave it that way. And that is your answer. So now solve this as an assignment. F of x is equals to 1 over square root of x plus 1 over cubic root of x power 5. So solve that one. This one using the differential notation. Thank you. Follow me on the other video, the next video, for rules of differentiation. Thank you.